Okay. We're on the graphical method of solving quadratic equations. So we know that before now that the quadratic equation is any equation of this form: a squared plus bs plus c equal to 0, where a is not 0 and a, b, c are constants. Now, looking at this, we have two functions, yes, because we cannot just plot this. So we use what, from the knowledge of what we saw, this means y equal to a squared plus bs plus c, and y equal to c. Yes, you could remember this is a quadratic function. So which is y. Here y is 0. That's it. So this means two functions, two different functions that intersected. So to solve a quadratic equation by graphical method, we need to plot these two functions. The first one, y equals a squared plus bs plus c, and y equal to 0. And I don't know, before now, another name for exercise is y equal to 0. So what was the implication of this? So the solution of quadratic equation by graphical method is the point of intersection of, it could be points, no points. So it could be R or is. So it depends. R, point of points. So points. Section. Two functions of y equals a squared plus bs plus c. That's the quadratic curve. And this y equals to 0, which is the x-axis. So that's it. So we know that a quadratic curve is either concave or down. Well, if it's either concave or concave, there must be an intersection between the curve and the x-axis for it to be solved by graphical method. Yes. So this, see, yes. So that's what to do. Nuclear. This is concave. So our main aim is the idea you must look at, it must intersect the x-axis, yes. So this is the y, this is y equal to, this curve now is y equal to the square plus bs plus c. Why this one down here, the x-axis. So this is the x-axis. So the solution, they see the solution. So this and this, that's the answer we're looking for. So, and the next thing is for you to plot a quadratic curve, you need a table of values. Or even if you're not given it, you need to generate table of values. So we solve three different equations. That's we plot three different graphs. So all the graphs you see will be either one of them. So let's start with the first one.
We are given the table and we're asked to copy and complete the table. That is, the table is for the relation y equals 2x squared minus 9x plus 9. They ask us to copy and complete the table, use it to draw the graph of y equals to 2x squared minus 9x plus 9, and after use it to solve these two equations. Before now, we know that once you are given a table of value and you're asked to plot the graph, first thing is to complete the table, even if you are not given the table. But in this case, they gave us some of the values. So they gave us some of the values. They always give you the complete values of x, or they might not give you any table. You now use values of x. That's just choose any value and substitute in the equation to get the corresponding values of y. So, but in this case, they gave us to, though it's advisable after you fill in the other values, that's the unknown, you cross-check the one given. Like as you can see, once I plug in, when x is 0 here, y is 9, so it's correct. So the other one, maybe if you test, you still get 0. So what I will do to avoid wasting our time, I'll just solve one for minus 1 and 1. I will paste the complete table, the remaining 3, so that I will move to the graph. So when x is minus 1, one of the unknown, you see that y is now, wherever I see x, I call it minus 1. So minus 1 squared minus 9 times minus 1 plus 9. So this is 2 plus 9 plus 9. So the value is 20. So the first value of x, that's minus 1, is 20. Let's check for 1. When x is 1, we see that y is now 2 times 1 squared minus 9 times 1 plus 9. So we see this is 2. But this minus 9 plus 9 is 0. So that's how we do for other values. So let's just paste the table so that we won't waste time. X, the minimum, is very important, so we need to locate the 2. For x, the minimum is minus 1 and the maximum is 5, as you can see. Y, for y, the minimum here is minus 1, while the maximum is 20. So what do you have to say? We have more positive than negative values, so our origin will somehow come down and it will move to the left, yes, so that it will accommodate more positive values of x. Like this, our origin will be located down here so that it will accommodate more positive x and more negative x. So that's how we know where to locate our origin. So our graph will be like this. Some students will just go straight and divide the graph into two. No, you need to know the values first, and again we need to know each of the grid lines. So for x, each grid line is very important. The formula is each grid line is an interval you are going over the total grid line. But before we do this, let's just go to the graph and locate our origin and axis. Then we now calculate. Well, for now we don't know the interval we are moving. Okay, that's our graph. So the next thing, that's our graph. Let's locate the axis and the origin. Okay, That's our y-axis. Let's duplicate it so that I will get x. Okay. We'll place it in any of the major grid lines. Okay, from the table, let me paste the table so that we know the maximum and the minimum. If I move it a little up, so if I count 1, 2, 3 to be 10, 1, 2, 3 to be 20, okay. And for x minus 1, 5, so if I count 1, 2, 1, that's, I'm using 3 cm, let me check, 3 cm, 1, 2, 3, 1, 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3, 4, so it won't be enough. Okay, let's make it 2. Okay, that's our origin. So I'm counting 1, 2, 3, 10, 1, 2, 3, 20. So that's our y-axis, and this is our x-axis. Maybe let me write this y-axis, or x equal to 0. That's another name. This is x-axis, or y equal to 0. That's the origin. And as you can see in y-axis, we are counting 3 cm to 10 units. That's our scale. And for x, we are counting 1, 2, 1, 2, so here is minus 1, 1, 2. As we are counting 2 cm to 1 unit. 1, 3, 4, 5. Okay. So we have our axis and origin. So we'll start, but before we need to check each of these small grid lines. Let's know the values. So for x-axis, so each grid line for x-axis, so for x, we are moving 1 unit, and we have how many total grid lines to that 1 unit? We have 10. Check. See, 5, 10. So it will be, each of them will be 0.1, each of the small grid line. And for y-axis, we are moving in 10 units, and we have a total of 15 grid lines. So this is 0.67, that's 0.667. So each of them is that. So if we want to locate any value, we now divide. So from this formula, if we want to locate any, that's grid line, that will total grid line to any value, we divide that value we are looking for, that's the interval, over each of the grid line. So depending on the axis, if it's x, we divide by 0.1. If it's y, we divide by 0.67. So it will help us to locate the values fast. So let's do it fast now. Okay. So we'll start. When x is minus 1, y is 20. So this one is visible. So it's easy to locate. So when x is 0, y is 9. So to locate 9, I told you we now divide 9 by each of the grid line to y-axis. Each grid line to y-axis is 0.667. So if we do 9 over 0.667, this is equal to 13.4. So like 13.5 grid line. So let's count. 13.49, which is 13.5. So when x is 0, so we'll count 5, 10, 11, 12, 13 points, so somewhere here. So that's it. When x is 1, y is 2. So we'll divide 2 by 0.669 so that we'll locate 2 and y. So we have 2 divided by 0.669. We have 2.9. 2.9, almost 3 grid lines. So 2 when x is 1, so 1, 2, so somewhere here. So when x is 2, y is minus 1. So minus 1 we divide, which is 1 divided by 0.667. So I have 1.4, that's 1.5 grid line. So when it is 2, so down 1.5. So this is 1.5 somewhere here. Okay. So when x is 3, y is 0. So it's here. It's visible. When x is 4, y is 5. So we divide 5 over 0.667. We have 7.49. That's 7.5 grid line. So we have 5, 6, 7, 7.5. So that's it. When x is 5, y is 14. So count 14 over 0.667. So we have 20.9. Is almost 21 grid lines. So count. That's 5, 10, 15, 20, 21. So that's here. So we are done with the points. So let's join the points. So we'll start with this. We'll move to that. 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 So that's our curve. Maybe let's change the color. Let's change the thickness and color. Maybe the color is okay. So that's our curve. Let's leave it blue. So we don't need this table again. So the curve is y equal to the table y equal to 2x squared minus 9x plus 9. Y equal to 2x squared y equal to 2x squared minus 9x plus 9. So that's the curve. So let's now use it and solve the equations under it. They said we've drawn the graph. They say use the graph to solve 2x squared minus 9x plus 9 equal to 0. So from whenever you're asked to use a graph to solve a particular equation, we transform the given equation to look like the graph we've drawn. So we have 2x squared minus 9x plus 9 equal to 0. So as you can see, this is what we plotted. We plotted 2x squared y equal to 2x squared minus 9x. So we have, these are the points of intersection of y equal to 2x squared minus 9x plus 9. That's the curve we plotted, and y equal to 0. Yes, we have two functions here. The first one at the left hand side, while the second one on the right hand side. That is y equal to 0, which is the x-axis. So go to the x-axis and see where so as you can see, the points so we see this 3 is part of it. So let's locate this. So we are looking for this, the value, the interval. So we need to count how many grid lines. So we have 5, 10, 11, 12, 13, 13.5. We have 13.5 grid line. Let me count 1, 2, 3, 13.5. So since we know that each grid line for x is, as we know, that is the interval we are looking for over the total grid line. Therefore the interval, that's what we are looking for. That's the value, is now each grid line for x times the total grid line. So, and each of these in x-axis is 0.1. We've calculated it as 0.1. So times the total grid line, we counted 13.5. So let's check whether it's 13 so that I won't make mistake. This is 5, 10, 11, 12, 13.5. So which is 1 over 10. 1 over 10, this should be 1.35. That's for the first value. That's the first value. So we shall x equal to 1.35, and the second value is visible, which is 3. So from the graph, that's the value, that's it, that's the point A and the point B. That's our 1.35. So that's the first solution. That's first question. The second question, they said to solve x squared minus 5x plus 4 equal to 0. X squared that's this first question. The second one, we have x squared minus 5x plus 4 equal to 0. I think that's it. Okay, so the next thing again is to do the same thing we did here. Transform this to look like the plotted function. So we need to transform that. So what do I notice? The first one has 2. But that's the coefficient of x squared is 2. But what we have here, x. So we multiply both sides by 2. So let's start. 2 times x squared is 2. X squared. 2 times that is minus 10x. 2 times 4 is 8 equal to 0. And the first one has minus 9x, so I have 2x squared. How do I get minus 9x? So I can bring in and still retain minus 10x. So it's like minus 9x minus x. Yes. So I've brought in minus 9x and still have minus x to make it up to minus 10x. So it's logical. Y9 is, I want to bring in 9. So plus 9 minus 1. So I've brought in the 9. And still subtract 1 to give you 8. So we are still in the right track. So I now write the first function, that's the one plotted, 2x squared minus 9x plus 9 one side, and move the remaining to the other side. So remaining is x plus 1. So we have two functions now. So this, the points, okay, these are the points of intersections. These are the points of intersections of y equal to 2x squared minus 9x plus 9. That's the plotted graph. And y equal to x plus 1. So we'll still plot a graph, because this is a linear graph and it's a slant line, not a horizontal line like the first one. Y equal to 0 is a horizontal line, x axis. So we need to plot this, but we don't need to waste time setting a table of values. We don't need to waste time, because for us to get a particular point, we do when x is 0, you see that y is 1 if you substitute, and when x is minus 1, you see that y is 0. So I think once we locate this and this, we'll get y equal to x plus 1. So let's locate when x is 0, y is 1. So we locate when x is 0, y is equal to 1. And remember, we are using the same graph. So I will know that each of the grid line for y is 0.667. So I do 1 over 0.667. So I get 1.49. So 1.5 grid line, total of grid line, that will give us 1. So we have 1. So this is the point. So let me use black. So this is 1.5 here. So that's when x is 0. Why is that? 1. So let's check when x is minus 1. Y is 0. When x is minus 1, y is 0. So which is here. So we join, and why join? We draw a line that will cut the curve, because that is the point of intersection. So we draw a very long line so that it will cut the second curve. So we are joining. So let's draw so that it will. Okay, let's change the thickness. So let's check the color. So let's label. We have, this is y equal to x plus 1. So let's locate the points of intersection. So as you can see, we are seeing a visible one, which is x equal to 1, and this is now up to 4. So and each of them is 0.1. So this should be 0. This is 3 points. That point D. So it's 3.9. So the answer, we shall x equal to 1 and x equal to 3.9. So that's the solution. So it's a tricky but easy question. Thank you.
So copy and complete the table of values for this. Y equals a squared plus bx plus c. So this is a quadratic curve. But there is a little problem. We don't know the values of a, because the only way we can complete this table is to get the values of a, b, and c. So then we substitute the values of x to get the corresponding values of y. So first thing is to get a, b, and c. And how do we do it? Before then, the quadratic curve is either written, this is one of the form. This one is the general form. But we can still write it in terms of the center. So a quadratic curve is either is always y equals a bracket x minus h squared plus k, or a bracket x minus alpha times x minus beta. So aside this one we are given, you can still write it in that form. So where the first one, where h comma k is the vertex, and alpha and beta are the x-intercepts. That's where y is 0. So that, but for this question we're going to use this because we are seeing the x-intercept. I'm using y equals a times x minus alpha x minus beta. A is also a constant. We're going to get it. So since what I just said now, x-intercept, that's where y is 0. So minus 3. So x minus 3, that's plus 3. And x minus 1. So to solve it, to finish up the function, we need to get the value of a. So choose any other point. I told you the best point to choose is the y-intercept. So at 0, 1.5. So we now have that y is what? 1.5. X is 0. So I have 8 times 3 times minus 1. And we know that 1.5 is 3 over 2. So this 3 over 2 is minus 3a. So solving for a, we now have minus 1 over 2. So the function now is y equals minus half times x plus 3 times x minus 1. So that's the quadratic function. So let's now fill up this. So this is now easy. This is easy to solve since we have x, but in case you don't have x-intercept, it will lead to simultaneous equation, yes, of 3 unknown, yes, like this one, this question. But there is no x-intercept. You see, so I'll solve this in another video. So let's finish up this. So we are now getting the value. Let's fill up this. So the ones we are looking for at x. So we fill up the table. So the next thing is to plot the graph. But before plotting the graph, you need to know the margin because you need to plot it so that it will be very large or very big. You need to know the margin. So as you can see, x is settled. X has the minimum is minus 4, maximum 4. So but y, the minimum is minus 10.5 and the maximum is 2. So the origin will go up so that it will contain more negative. Yes. So let's. Okay, so we have equal positive and negative for x, and but for y we have more negative. So the origin will go up. So x, if I count 1, 2, 3, 4. 1, 2, 3, 4, 7. Okay. So if I count into 2, 2, 4, 6, 2. Okay. So we'll have we're going 2, 2 for 2 cm for x. So we'll have 1, 2, 3, 4. So again we have -1, -2, -3, -4. So okay. So for y we are moving 2, 2. So we have 2. This is -2. This is -4, -6, -8, -10, and -12. So let's now look at the points. So and also we still have a little problem. If you notice, we have -7 points. So let's calculate each of the grid line. Yes, each grid line for x and each grid line for y. That's the small, the minor. No, okay. So for x, each grid line. Yeah, so each grid line is always the interval we are moving over the total grid lines. So for x, we are moving 1 interval. So 1 over the total. We have 5 grid lines to that one, 5, 10. So 1 over 10. So it's settled for x. Each of the grid lines is 1 over that, 0.1. Y for y, we are moving in 2, 2. So we have 2 and 2 2s, and each of them, so 5, 2 over 5. So each of them will be 0.4. That's each minor grid line is 0.4. That's small lines. Yeah. So now, since we are looking for -7.5, because -4 is already for x is set, you can see it on the graph. So since we are looking for -7.5, so what do? We want to get the total grid line that will give us minus. So see what I'm saying. This implies if you are looking for the total grid lines, is the interval over each grid line. So for y now, since I'm looking for 7 points, so the interval now is 7 points. Remember, negative just the direction. Negative shows it down. Over each of the grid line is 0.4. Yes. So let's know how many grid lines that will give us 7.5. So this is 75 over 4. So that under 3 in 35. 35 is 8. That's 2. Remember 3 in 37 and 2. We have 18.75 grid line. Was 18 point maybe 8, maybe 19. So let's check. So we are moving, see where x minus 4 is. So we move down how many grid line? 18 or so, 5, 10, 15. You see? 5, 10, 15. So count 16, this small one, 17, 18 points. So it should be in somewhere here.
So 5, 10, 15, 16, 17, 18, so somewhere here, 190. So that's it. So for minus 3, x minus 3, y 0, so on the x-axis, so the other one, minus 2, 1.5. Again, we're not seeing 1.5. So that same way, 1.5 over, so to get 1.5 over 0.4, that's 15 over 4, that should be 3.5, that's 15. 3 remainder 12, that's 3. And that's so 3.75, so 3.8, so we'll count when x is what? Minus 2, y is what? 1.5, so we'll count this positive, so we'll count up. So 5 is not up to, so we'll count 3 points, so we'll have 1, 2, 3, you get 3.7 until 3 instead of 4, so it should be exactly. So that's when x is minus 2, y is now 1 point. So this one is 0. Okay, 1 minus 1, 2. Minus 1, 2, so it should be here. It's same, minus 1, 2. So which one again? 0, 1.5. So remember this is 1.5, so 0, 1.5 should be here also. So which one again? 1, 0 on the x-axis. So which one again? 2.5. So minus 2.5. Okay. So that same way we do 2.5 divided by, so that we'll see over 0.4, which is 25 over 4. So 25 over 4 is 6 and 1 and 10, 2, so 6.25. 6.25. So we'll move to 1 is 2. We'll move 6 points, so this is 5. 6 points, so just pull that 5. 6 around here. 6. Is 6. So when x is 3, y is minus 6 again. Okay, we can see minus 6 is there, so it's, and finally when x is 4, y is minus 10 points. So we still do that same thing. 10.5 divided by 0.4, which is 105.4. So we'll count, this is 2 and 2 in 25, 6 and 10, 2, 25, so 26.25. So we'll count 26, so 5, 10, 15, 20, 25, 26, 2, so somewhere. So let's join. Let's now join. we are joining. We are joining. We are joining. So let's make the line tick so that you can see it. Maybe let's change the color. Let's change it to white. Okay. So this is now y equals what? So the graph is y equals so this is y equals minus half x plus 3 x minus 1. So we've plotted that. So again, the axes, we have done the first and second question. We've done first. So use the graph to solve this, where that is equal to 0. So remember that this is now equal to the equation is now as squared plus bs plus c. So what I've plotted, where is 0? So meaning x inter, so as you can see at, so I'm solving the I part of b. So meaning where y is 0. So as you can see, y is 0 at minus 3 and 1. So therefore, the solution is x equals minus 3, x equals minus 3, or x equals 1. So coming to the second one, that's where it's very tricky. They say 2x, use it to solve 2a squared. So we're given 2a squared minus 2a squared plus 2, that's bracket 2b minus 1 x plus 2c minus 3 equal to 0. Okay. But remember, the original function is what? If you remember, the original function is y. Let me just write it up here. Y equals as squared plus bs plus c. And we're asked to use it and solve this. So we need to transform this one to look like that. So, and if you check the coefficient, what I have here is a, but what I have here is 2. So I divide both sides by 2. So I have as squared plus 2b minus 1 over 2x plus 2c minus 3 over 2 equal to 0. So we are getting it. So this is as squared plus this is b minus 1 over 2x plus c minus 3 over 2 equals 0. And if we open up, we have a squared plus bx minus 1 over 2x plus c minus 3 over 2 equals 0. So we now have two functions which are a squared plus bx plus c. And if you move, let's move this one to the other side, which is half x plus 3 over 2. So using that same thing we did here, you know why the answer is x equals minus 3 and x equals 1 in the first one is the point of intersection of the curve, which is y equals a squared plus bs plus c, and the x-axis, another name for x-axis is y equal to 0. So that's why where they intersected, that's why the answer is minus 3 and 1. So now that same thing now. We have these are, or it might be more than one. These are the points of intersection of y, the original curve, and another curve which is y equals 1/2x plus 3/2. Yes. So, but we've done the first one, that's a squared plus bs plus c. So we need to draw y equals half x plus 3/2. And y equals half x plus 3/2 is a line, it's a straight line. The curve is a line. So we need to draw the line. And how do you draw a line? You need 2 points. So for you to draw a particular line, you need 2 points. So see the line now. The line is y equals half x plus 3/2. Since I need 2 points, let's choose the point on the graph so that we'll make it. So if we choose x equals 0, yes, it's on the point. It's within the boundary. So choose the one that will see that are accommodated. Choose the point that are accommodated on the curve, that's the table. So don't choose something that is out of the grid line. So let's choose x equals 0. So if I choose at x equals 0, you see that y is now 3/2. Yeah, which is 1.5 is there. And also if I choose at x equals maybe -2. Because is it there? It's there now, it's on the table. X equals -2. Let's know whether y is there after substituting x. So if I put y, give now half -2 plus 3/2. This is -1 plus 3/2. So that's -1 plus 1 and 1. So I think we are left to as half, which is on the curve 0.5. Yes, it's accommodated there. 0.5 is there. Okay. So let's now draw the line. So first point, I've located the first point, which is what? At x equal to 2, y equal to 1.5. So at x equal to 0, y is 1. So this is my first point. I'm about to draw the line. So that's my first point. And the other, when x equals -2, y is 0.5. So again, let's check 0.5. 0.5, we now have 0.5 over 0.4, which is 5/4. That is 1.25. That's 1.0. We'll go. So why the second point? I told you for what we've got that when x is -2, y is 0.5, which is 1.25 billion. So it should be here. Oh, so let's join the line. Let's join the point so that we'll get the line. So that's the line. So the line is y equals half x. Always level. Y equals half x plus 3/2. So from our answer, that's the x value. That's the answer is now -3. So therefore, therefore the solution is either x equals -3 or x equal to 0 from the, as you can see, that's it. That's called the intersection of the two curves. So here x is 0, right here x is -3. So that's the
End of the solution. So thank you.
Okay, copy and complete the table of values for this quadratic function. These are the questions under it. But we know that for you to solve this, we need to fill up the table. And we have a little problem because we don't know the values of A, B, and C. So we need to get these values before we can substitute. That's for each corresponding value of X, we now get Y. And it would have been faster if we are given the x-intercept, that is where y is 0. We now use the second form of quadratic because we have three forms. This is the general form. We still have other forms. So this is the one they gave us, is the general form. We still have y equals a times x minus h squared plus k, x minus alpha times x minus beta. So the first one is where hk, that
is the vertex, and alpha beta are the x-intercepts. Yes. So we're not going to use it because there is no, as you can see, there is no s-intercept here. That's where y is 0. And also there is no coordinate of the center, that's hk. I just told you aside this one is the general form. You still have the quadratic function in terms of the center and in terms of the s-intercept. So let's now, if we lead to simultaneous, let's choose 3 points here. Since we have A, B, and C.
And to make it easier, you choose the point where the values are very small. So I will choose x minus 1, 3, that's y 3. So this, and this. Other, these ones are very large. So let's now start, let's fill up. So at x, but to make our solution faster, I will start by choosing this one. So the first point I will get, it will help, since x is 0, it will help us to get the one of the unknown first, which is c. Yes, so if we choose x equals 0, y is minus 3 at x, zero y minus 3, you see that y is minus 3 and yx is 0. So it will be faster to get one of the unknown, which is c. So we now have that c is now minus 3. So we've gotten the one of the unknown. So let's choose another point at, I think, minus 1, x minus 1, y what? 3. So x minus 1, y 3. So we substitute again. X minus 1, y 3. So this 3 equals a minus 1 square plus b times minus 1 plus c. So instead of writing plus, we now replace it with minus 3. Are you seeing why I had to get c first before any other? So this is 3, this is a, this is minus b, this is minus 3. So making the equation to be 6 equals a minus, so let's call it equation, that's equation 1. So the other one at x1, y minus 5. So 1 minus 5. So y is 5 minus 5 and x is 1. So it will still replace c as minus 3. I've told you that's the reason I got it first. So this is minus, this is a, that's Okay, this is 1, sorry. So this is plus b minus 3. So I have that this is minus 2a plus b. So that gives equation 2. So we have two equations now to solve simultaneously. So let's solve by by elimination. So we'll add equation. Let's add in equation 1 and 2. Equation 1 and equation 2, so that we eliminate b. We'll see that by adding that 6 plus minus 2 is 4. A plus a is 2a, so b is gone. So we'll solve for a. We see that a is 2, so we've gotten the value of a. Since we've gotten the value of a, we'll choose any of the equation and substitute a as 2. So let's choose equation, I think equation 2 is better. So from equation 2, we'll see that if we solve for b, b is now minus 2 minus a. Minus 2 minus a, which is minus 2 minus 2, which is minus 4. So the value of b is minus 4. So we've gotten the quadratic function. Therefore the quadratic function is now y equal to a is 2, so 2x squared minus 4x minus 3. Okay, this is the quadratic function now. So this is the quadratic function. So let's now fill up the table. Yes, so we'll start the first one when x is minus 2, so we'll substitute. So when x is minus 2, so y is now equal to y is equal to 2 minus 2 squared minus 4 times minus 2 minus 3. So this is 8 plus 8 minus 3, so that should be 13. So when x is minus 2, y is 13, so we substitute. This is minus, so this is 13. So the first value now we've gotten that. So the other one, when x is 2, let's get for y. So when x is 2, so we now have that y is now 2 squared, 2 times 2 squared minus 4 times 2 minus 3. So this is the same 8. This is 2, not minus. This is 2. That's minus 8 minus 3. So we get minus 3. So when x is 2, y is minus 3. We substitute again. This minus 3. So the next point, when x is 3, let's get for y. When x is 3, so y is now equal to, substitute 2 3 all squared minus 4 times 3 times 3 minus 3. So y is equal to, this is 18 minus 12 minus 5 minus 3. So this should be, that's 18 minus 15, that should be 3. So when x is 3, y is also 3. We write 3 3. So the last point now, when x is 4, when x is 4, So y is now equal to 2 times 4 squared minus 4 times 4 minus 3. So to solve this first part, I will factor 4 squared so that it will be easy. I have 2 minus 1 minus 3. Do you get? You know, I'm trying to avoid, because this is 4 squared, so this is now 16 minus 3. That is 13. So we have x is 4, y is 13. So this is 13. So we are done with the table. Let's now plot the graph. Yes, but before you plot the graph, you need to check, because we have to check the maximum and minimum. So do you see that the minimum value for x, the minimum is -2, the maximum is 6, so we have more positive than, so our origin will shift to the left. Yes, for x. So for y, we have minimum of -3, maximum of 45, so it will go down. So our origin will be down left. Yes, so that the graph will be very big. So that's what you have to consider, so that you have to accommodate the points. So let's do it. So I'm counting 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is 3. Meaning 1, 2, 3. This is 1.5. So 1, 2, 3, 4, 5, 6. This is 6. Yes. And this should be 1, 2, 3. This is 4.5. Okay, y this is 1, 2, this is 1.5, that's minus. So y for y, since the maximum is 45, so I'll count 1, 2, 3, this is 20. 1, 2, 3, this is 40. Okay, so this is -20 down here. Okay. So now to locate the point will be very hard. Yes, because as you can see, the point is far, so like 13. So we're going to use this method, yes, to each of the grids. So we need to know each of the minor grid lines. So for each grid line, we use this formula. Each grid line, remember why I had to do this is to make the graph very large. So if we plot this, it will be very, very large. So we are going to use this formula. Each grid line is the interval you are moving, or what you want to get, over the total grid lines. Yes, so for x now, we are moving at an interval of 1.5, and the total grid line to that 1.5 is 5 times 15, so 1.5 over 15. So meaning this 15 over, I think 1/5, that's 1/10. So each of them is 0.1 for x. Y for y, you are moving at an interval of 20, and how many grid line? 5 times 15, so 20 over 15. This is 4 over 3, meaning 1.33333. So but that one is by the way. So let's, each of these grid line for x is 0.y, for y is 1.4 over 3 or 1.33. So to locate, so which implies that if I'm to locate the total grid line that will give us a particular value, we now do interval over the total, that's making it the subject of formula here. Interval over the total over each grid line. So let's do it so that you see what I'm saying. Since I'm looking for -2 is set to, okay, -2 is not seen there. You see minus, what I'm seeing is -1.5. So to locate minus 2, remember minus just the direction. So for x, if I'm to locate minus 2, so I'll do 2. I told you the 2 is just minus, the minus sign is the direction, over each of them is 0.1. Do you get what I'm looking for is 2 over that. So I have how many? That's 20 grid lines. So to locate 2 now, see 20 the grid line, 5, 10, 15, 20. You see it? And to locate, so meaning here is 2. Here is 2. 5, 10, 15, 20. So it's there. Let's locate 3. Oh, sorry, 13. So for y now, y is now 13 over each of the grid line is what? 4 over 3. Let me use 4 over 3. So meaning 39 over 4. So I have that's 30, that's 9 remainder 3 and 37.5. So 9.75 grid lines. So remember 13 positive, so it's up. So I'm counting now 5, 10. This is 9 points, so not up to 10. 5. So it should be here now. So 9 point something closer to 10. So these points at x equals to y 13. So that's the first point. Why the second point? So that's why I say to make it big, you need to be, and meanwhile I didn't label the axis. Always label your axis. This is y axis, y this is x axis. So to locate minus 1, 3. So also 1 minus 1 is not seen, 3 is not seen. So let's do the same. For x is minus, I told you the minus just the direction, 1 over 0.1, which is 10. So 10 grid lines. So x will be 10, 5, 10. So C1 here. Y for y is 3, I think 3. So 3 over 4 over 3. 3 over 4 over 3, that's 9 over 4. That's 2.225. Yes. So we've got 5, 10 for 1, that's for minus 1, and 2.25 grid lines. So move up how many times, because it's positive. 1, 5, 10 for 1, C1 here. So move 1 to 2 points, so it's somewhere here. So that's it. Why when x is 0 minus 3, so down, the same thing, 2 point down. So C0 now move 2 points, 1, 2, just 2 points, so somewhere. So that's it. When x1, 1, the same 1, 10 grid lines. So let's get for 5 minus down. So 5 over 4 over 3, which is 15 over 4. That should be 3.75. That's, yes, 3 points. So 3.75, almost 4 grid lines. Down. So 10 is for 1, 5, 10. So move 3. 1, 2, 3, almost 4. Okay. So the next one is 2 minus 3. So 2 is, we've done 2 is how many grid line? 20. And we've also done 3. Okay, 3 is in there, so makes it easy. 2 minus 3. Okay, 2 minus 3, so downward 2 and So move 20 grid lines to 5, 10, 15, 22, and -3, meaning we move the same units down. So we move 1, the same thing should be here. 1, 2, 3, somewhere here. So because it's -3, so 3, 3. 3, we've all calculated 3 for x. Okay, no, so 3 over 0.1, meaning 30 grid line, and we've done 3 for y, which is 2.25 grid line, but it is positive, meaning up. So 30 grid line for 3. Okay, C3, we see 3 here, so y up 2.2 grid lines up 1, 2, so somewhere here. So the next one is what? So that's 4 and 13. 4 will be 4 over 40, as 4 over 0, meaning 40, and 13. We've done 13 before, the same place. So let's just 45, 10, 5, 10, 15, 20, 25, 30, 35, 40. So the same place here. So 45, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30, 35, 40. So move almost here. So y 5, 27. So 5 will be 50. 5 over 0. So let's check for 27. So for y 27, I have 27 over 4 over 3. Which is 27 times 3 is 81 over 4. Yes, 81. That's carry 2. Okay, so we have 20. So 10.25. Yes, that's 20.25. So we move 20. How many down or up? So we move up. Okay, so 5 will be 50, so no need. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and we move how many up? 25, 10, 15, 5, 10, 15, 20.25. So it should be somewhere here. 5, 10, 15, so somewhere here. So the next one is 45 and 6. So we can see 6. So let's check. 45 will be 45 over, to get 45 over how many? 4 over 3. So this is 5 carry 1, 135 over 4, and this is 3 in 15, 3. So that's the 3.75. So we'll move how many? 3.75 grid lines up. So 5, 10, 15, 20, 25, 30, 1, 2, 3. 1, 2, 3. So somewhere here. So we've gotten the point. So the next thing is to join the points. So we join the points. So let's join. So we've joined the points. Let's change the color to, which one is good? So I change it to, let's change this. So let's increase the thickness. let's increase the thickness so that you can see it. Okay, that's the curve, which is y equals, this curve is y, this is y equals y equals 2x squared minus 4x minus 3. So always label. So that's the curve. So they asked us to use it and solve. We've done this. So use it and solve that. The first bi, as squared plus bs plus c equal to 0. You know y is 0, meaning x-intercept. That's the point of intersection of x-axis and the curve. Yeah. So this is, so as squared plus bs plus c equal to 0 is the point of intersection of the first curve, which is what we are given, y equals as squared plus bs plus c, and y equal to 0, and y equal to 0 is x-axis. So go to the graph. The question is telling us go to the graph wherever the, so another name for x-axis is y equal to 0. This is y. So where did they intersect? So the answer is this point. So this point, maybe A, let's call it A. This point A, and this is point B. So the answer is point A and B,
which are x equals minus 0.5, x equals to 2.8. Yes. So these are the answers. We're coming to the second question.
We need to do some algebra. So we are given this. Let's copy it. Let's paste it. So we have a, okay, so we have, so see, the same way we need to get as squared plus bs plus c. So any other thing we get, we find their point of intersection. So first of all, we open up this as squared plus bx plus 2x plus c minus 2 equal to 0. We now have as squared plus bs plus c. We move this one to the other side, is now minus 2x plus 2. So what's the meaning of this? Okay, this is the point, this is the point of intersection of the first curve, which is the one we plotted already, and y equals minus 2x plus 2. So, but we need to graph. We've known, as you can see, the graph is the as squared plus bs plus c is this one, the curve. So we need to draw the graph of minus y equals minus 2s plus 2, and this is a line, a slant line. So let's draw the line, and for you to get a particular line, you need 2 points. So we need only 2 points for us to get a line, a particular line. So let's choose points that are within the graph, that's the grid line. So if I check x0, 2 is within there, yes. So at x equals 0, we see that y will be 2, and 2 is within here. Yes, y2 is there. 2 is within this interval. And if I check x equals minus 1, so at x equals okay, let's make it 1, because 1 is already there. Y will be 0. Yes, which is also. So let's locate these 2 points. When x is 0, y is 2. And I think we've plotted 2 before for y. Let's check. Have we plotted 2? on the table. Let's check whether there is where x y is 2. Okay, let's get y equals 2. So let's get y equals 2. So I have 2 over how many grid lines? 4 over 3 each of them. So this is 2 times 3 over 4. That's 3 over 2. That's 1.5 grid line. So x0 y. So 1.5 grid line up since it's positive. So let's go x0 y 1.5 grid line. So 1 somewhere here, 1.5. So that's the first point of the line. So the second one, x1, so 1 with 1 over 0, so 10, and so 10 grid line. So 1 and 0. So where x is 1, see it's 10 grid line. 10, see it here. So here, and y is 0. So on the axis. So this is. So we join these 2 points. That becomes the line. So let's join it. So let's join it. Okay, that's the line. That's the line. So let's label it. This is y equals. Let's label it. Let's move it down small. So this is y equals. The line is y equals minus 2x plus 2. So where, remember, the solution is the point of intersection. So the point of intersection is this place. So let's call it C and T. So that's the solution. So let's trace down. This is 1, 2, 2.5. That's 5, 10, 5, 10, 11, 11, 12, 13. So 13 grid lines. So that's minus 1.3. So we shall. So the solution is now, we shall x equals minus that's 1.3, or x equals, let's check, this one is, let's check this, 5, 10, 15, 20, 21, 22, 23, 2.3. So which is 2 points, that's it, 5, 10, 15, 20, 1, 21, 2, 3, so 2.3. So that's the solution.